Hey guys, so now that we've used Khan Academy for the last couple weeks, I wanted to get back to doing a majority of what I'm going to be teaching through these videos and book assignments. I just wanted to be sure that you guys get comfortable with Khan Academy as moving forward. That's just another great resource for you guys as we're learning different things to be able to get on and watch their videos. Or I might use some of their assignments and quizzes a little bit moving forward. But again, for the most part, we're going to move back to doing lessons this way and being able to just do assignments out of the book. So today we're going to do the last lesson from Chapter 7, which you guys is a lot of what you guys were doing on Khan Academy of working with radical expressions, things like that. I know we kind of moved away from that the last few days, but we're really going to be coming back and hitting some of this stuff hard again. So today's lesson is going to be on solving radical equations and inequalities. So for this, a radical equation is any equation that has radicals that have variables in the radicand. So again, remember the radicand is when you have a radical or a square root sign. If you have something like x minus 3, the radicand is whatever is under the radical symbol. So again, a radical equation is an equation with radicals that have variables in the radicand. A radical inequality is the same thing, except instead of an equation, it's an inequality, so it's going to include less than or greater than. And then an extraneous solution. We've talked about these a little bit throughout the year, but this is where it's going to be really important to remember these. An extraneous solution is an answer that does not satisfy the original equation. So again, this is where you could have a problem where you come up with an answer, but it doesn't actually work to solve the equation that you're working with. So especially on these, always be sure to check your solutions. So with that, let's go ahead and get into some examples. So here we're working with radical equations. Solve each equation, check your solution. So when you solve a radical equation, the first thing you always want to do is you want to move your anything that is not under the radical to the other side. So here we've got the square root of x plus 1 plus 2 equals 4. So since the plus 2 is not under the radical, we want to move that to the other side. So then we would have the square root of x plus 1 is equal to 2. Now, just like we've learned in the past, in order to get rid of a square root, we are going to square it. So we need to square this side. That will cancel out the square root. Whatever we do on one side of the equals sign, we have to do on the other side. And that will give us x plus 1 equals 4. We subtract 1 from both sides, and we would get x equals 3. Now that we've found that, we want to check to make sure that answer works. So in order to do that, we would plug 3 in for x in the original equation. So the square root of 3 plus 1 plus 2 equals 4. Or the square root of 4, which is 2 plus 2 equals 4. 4 equals 4, that works. So x equals 3 would be our solution here. So now that we've done that, let's go ahead and do another example. I'm going to go ahead and skip down to this one. We'll come back to the other two. So 5 equals the square root of x minus 2 minus 1. So here, again, same steps. We need to add 1 to both sides, so we're left with just the radical on the right side. So 6 equals the square root of x minus 2. We're going to square both sides. 30 36 equals x minus 2. So x equals 38. Then we want to plug that in to check it. And we would get 5 equals the square root of 38 minus 2 minus 1, or 5 equals, this would be the square root of 36, so 6 minus 1, 5 equals 5, that works. So x equals 38 would be our solution. Now, on a problem like this one here, where we have radicals on both sides, square root of x minus 15 is equal to 3 minus the square root of x. So on a problem like this, we could subtract our 3 over, but then we'd have the square root of x minus 15 minus 3 is equal to the negative square root of x. Now really there, we're just moving that 3 from one side to the other. We're never going to end up with only the radical on one side. So on a problem like this, you're going to go ahead and square both sides right off the bat. So here, just like normal, those cancel each other out. So x minus 15 is equal to, now here we have a difference of two squares, or not a difference of two squares, sorry. If we go back to our patterns that we talked about last chapter, we know that if we have 3 minus the square root of x squared, or in this case, really, a minus b squared in any case, our answer is always going to follow the same pattern. It's going to be a squared minus 2ab plus b squared. So in this case, what that would come out as, a squared, which is, a is 3, so 3 squared is 9, minus 2 times a times b. So 2 times 3 is 6, times the square root of x. So 9 minus 6 root x, plus b squared. The square root of x squared is just x. So now we can go ahead and take our necessary steps to solve this. So I'm going to go ahead and I'm going to subtract x from both sides. So when I do that, my x's actually cancel on both sides. So I'm left with negative 15 equals 9 minus 6 root x. Now I'm going to subtract 9 from both sides. So negative 24 equals negative 6 root x. Divide by negative 6. So those cancel. And I'm left with 4 equals the square root of x. Now in order to get rid of my square root, I'm going to square. And I get x equals 16 as my answer. Now let's go ahead and check that to see if it works. So when I check my work, when I plug in 16, I get the square root of 16 minus 15 is equal to 3 minus the square root of 16. So the square root of 16 minus 15 gives me the square root of 1 equals 3 minus the square root of 16, which is 4. Square root of 1 is 1 equals negative 1. Now here, 1 equals negative 1. That does not work, so we would say this is an extraneous solution. So our answer would be no solution in this case. Now let's walk through one more of those. Here we have the square root of x plus 15 is equal to 5 plus the square root of x. Now again, we're going to start by squaring both sides. Since this side is all under the square root sign, that just cancels. I'm left with x plus 15 on that side. Now here on the last slide, or on the last one we did, since it was minus, since we were squaring a difference, it was a squared minus 2ab plus b squared. Here, since we're squaring a sum, it's going to be a squared, which would be 25, plus 2 times a times b, which 2 times 5 is 10, times the square root of x, plus b squared, which would be x in this case. Then we just need to solve. Now again, if we subtract x from both sides, those cancel. 15 equals 25 plus 10 root x. Subtract 25 from both sides. So negative 10 equals 10 root x. Divide both sides by 10. And we would get negative 1 equals the square root of x. When we square both sides, we would get 1 equals x. Now, if we go ahead and check that, again, if I'm moving a little too quickly for you, these notes are up on Schoology for you to follow along as well. So now when I plug it in, I would get the square root of 1 plus 15 is equal to 5 plus the square root of 1. So here, square root of 16 is equal to 5 plus 1, which gives me 4 equals 6. Again, that does not work. It's an extraneous solution. So I would say no solution. So that is solving radical equations. Now, moving forward, solving a cube root equation. So here I have them written as, like here, 5n minus 1 to the 1/3 power. If you remember, 5n minus 1 to the 1/3 power is equal to the cubed root of 5n minus 1. So even though I have them written a little bit different, these are the same thing. So just like in order to get rid of a square root, we square an expression. In this case, in order to get rid of the cubed root eventually, we are going to cube the expression. But first, we need to do the same thing we were doing on that last slide. We need to get that cubed root by itself on one side. So in order to start, I'm going to add 2 to both sides, which is going to leave me with 3 times 5n minus 1 to the 1/3 power equals 2. Then I need to get rid of this 3. Since they're multiplying, we're going to divide. So those cancel. So now I have 5n minus 1 to the 1/3 power equals 2/3. So now, in order to take my 5n minus 1 to the 1/3 power, again, that's the same as the cubed root of 5n minus 1. So I'm going to take everything in there and I'm going to cube it, which means I have to do the same thing on this side. So over here, that's really just canceling that 1/3 power. So here I'd be left with 5n minus 1. Then when you cube a fraction, remember you have to cube the numerator and the denominator. So 2 cubed would be 8. 3 cubed would be 27. Then I'm going to add 1 to both sides. So I'm left with 5n equals, now here remember, if we're adding 1, that's really like we're adding, since it's a fraction, instead of adding 1, I could also say plus 27 over 27. So 27 plus 8 would give me 35. Over 27. Then I'm going to divide both sides by 5. So here that's going to cancel on this side. Dividing by 5 is the same as multiplying by its reciprocal, 1/5. Then I can simplify before I multiply. That 5 is going to become a 1. 35 is going to become 7. And I'm left with n equals 7 over 27. Then again, you want to go back and check your answer. In this case, I'll tell you it does work. So 7 over 27 would be our answer there. On this next one over here, I am going to go ahead and rewrite this one as a cubed root. So instead of looking at this, we're going to look at the cubed root of 3n plus 2 plus 1 is equal to 0. So I'm going to start by subtracting 1. I'm left with the cubed root of 3n plus 2 is equal to negative 1. Now again, in order to get rid of a cubed root, you need to cube both sides. So that cancels out the cubed root. I'm left with 3n plus 2 equals negative 1 cubed, which is negative 1. Subtract 2 from both sides. 3n equals negative 3. Divide by 3. And n equals negative 1. Now, if we go back and plug that in and try it, I'm going to have the cubed root of 3 times negative 1 plus 2 plus 1 equals 0. So the cubed root of negative 3 plus 2, which will give me negative 1, plus 1 equals 0. Now the cubed root of negative 1, so what times itself 3 times equals negative 1? Our answer would be negative 1 plus 1 equals 0. 0 equals 0, so that does work. So our solution would be n equals negative 1. Now I'm going to add one more in here. I know at the top of the page it said solving a cubed root equation, but I'm going to throw in one more here. This is going to be a fourth root equation. So again, instead of looking at this one, I'll go ahead and write it as an actual fourth root. So the fourth root of 2y plus 6 minus 2 equals 0. So again, start by getting the radical by itself. Fourth root of 2y plus 6 equals 2. Now this time we have to raise to the fourth power to get rid of the fourth root. So 2y plus 6 equals 2 to the fourth power, which is 16. Subtract my 6, I get 2y equals 10. Divide by 2, y equals 5. Then let's go ahead and check that just to make sure it works. So I'm going to have the fourth root of 2 times 5 plus 6 minus 2 is equal to 0. Or the fourth root of 2 times 5 is 10 plus 6 gives me 16 minus 2 equals 0. Now here we knew that 2 to the fourth was 16, so the fourth root of 16 is going to be 2. 2 minus 2 is 0, equals 0. That does work. So y equals 5 would be our solution for this one. Now, one more slide here. We're going to work on radical inequalities. So radical inequalities are going to be very similar to solving radical equations, just with one added step. The added step here is going to be that the first thing you always have to do is take whatever is under the radical, again that's called the radicand, and set it greater than or equal to 0. Because we know that in order to get a real solution for a problem involving a square root, it has to be greater than or equal to 0. Otherwise, it's going to be an imaginary number. So I'm going to say 4x minus 4 is greater than or equal to 0. Then I solve for x. So 4x is greater than or equal to 4. X is greater than or equal to 1. So that's going to be part of our solution. Now the second part is just going to be solving it like we did before. So 2 plus the square root of 4x minus 4 is less than or equal to 6. So now I want to subtract 2 from both sides. Square root of 4x minus 4 is less than or equal to 4. Square both sides. 4x minus 4 is less than or equal to 16. Then I solve for x. So add 4. 4x is less than or equal to 20. Divide by 4. So x is less than or equal to 5. So here, I know that x has to be greater than or equal to 1, and x has to be less than or equal to 5. So I can write my solution as two different ways. I can say x is greater than or equal to 1, and x is less than or equal to 5, or I could write it as 1 is less than or equal to x, which is less than or equal to 5. Either one of those would work as the solution. So again, you always, when you're solving a radical inequality, you always want to start by setting the radicand greater than or equal to 0. So you'll get one part of the solution. Then you solve the radical inequality just like we had solved the radical equations before. I'm going to go down to this bottom one here. So again, I'm going to start out by setting this greater than or equal to 0. So 2x is greater than or equal to negative 2. X is greater than or equal to negative 1. Now I'm going to solve the inequality. So subtract 1, I get the square root of 2x plus 2 is greater than or equal to 4. Square both sides. 2x plus 2 is greater than or equal to 16. 2x is greater than or equal to 14. So x is greater than or equal to 7. Now in this case, on the one up above, we ended up with x is greater than or equal to 1. If we think of it on a number line, we had 1 and we had 5. We knew that x was greater than or equal to 1, and we knew that x was less than or equal to 5. So our solution was everything in between those two numbers. Now if we take a look at this one that we just solved, and think of our two solutions on a number line, we're going to have negative 1 and 7 on that number line. And we have x is greater than or equal to negative 1, and we have x is greater than or equal to 7. Now our solution on this has to be where both expressions are true. So the only place that both expressions are true is starting at 7 and moving to the right. So on this one, we can actually forget about the x is greater than or equal to -1. And we can just state for our solution that x has to be greater than or equal to 7 because that is what makes both of these solutions true. It has to be the area that both of these happen. So that is solving radical inequalities. Again, these notes in the assignment are going to be up on Schoology. Otherwise, there's the assignment as well. As you're going through and working on this, feel free to reach out to me. As always, if you have questions, I'm more than happy to get on Zoom with you guys or call or email or anything to help you guys out. Hope you guys are doing well. If there's anything, even besides math, that you guys are needing, feel free to reach out to me. Feel free to reach out to any of your teachers. And yeah, hope you guys have been doing well, and good luck on your assignment.